So in this video we're going to talk about ideal gas law and why we need it. So we learned in Unit 5 about molar volumes, or the volume of a mole of a gas. And we learned that the volume of 1 mole of gas particles at standard temperature and pressure is 22.4 liters. But this begs the question, what if a gas is not an STP? Remember that standard temperature and pressure is 1 atmosphere and 0 degrees Celsius. So we want to have some way of quantifying moles and relating that to pressure and volume and temperature of the gas when we're not at those standard conditions. And that's what the ideal gas law does for us. But there's some certain considerations that we need to look at when we're thinking about ideal gas law. So what is an ideal gas? So an ideal gas is a gas that always stays a gas no matter what the conditions. Now we know based on the first video that we learned about states of matter and phase diagrams that substances change their state based on pressure and temperature. So an ideal gas doesn't really exist. We say that in an ideal gas, particles have no volume whatsoever. We know that anything that has mass is going to be taking up space and is going to have volume. However, in ideal gas, we assume that the volume is 0. Now lastly, and this is important, it says that particles of an ideal gas do not attract each other even when they're really close together. However, real gases, when they're really close together, there is going to be some attraction between those particles. So when particles get really close together is when the pressure is very high or the temperature is very low, and we bring those gas particles close to one another. And typically what would happen for that substance would be that it would turn into a liquid and then into a solid the further left and to the right further left and up we get in this graph. So the higher the pressure and the cooler the temperature, the more likely it is to be liquid or a solid. So essentially what we say is an ideal gas always stays a gas. It's never going to change its state. Now, why is this useful to us? Well, first of all, a lot of real gases act like ideal gases under certain conditions. If we're not working at extremely cold temperatures or at high pressures, then a real gas is actually going to behave like an ideal gas. So the equation for ideal gas law would apply realistically to those ideal gases. The other thing that it allows us to do is it allows us to perform calculations with gases without having to worry about whether or not a phase change is going to occur. So when we're doing ideal gas law problems, we can just assume that it always stays a gas, and we don't have to think about the fact that it might actually become a liquid or a solid. And this will make a little bit more sense when you watch the next video, which I will then go over how to calculate ideal gas law and how to relate moles at different temperatures and pressures.